Okay, here we are in Chapter 5, Section 6, and we're looking at inequalities in one triangle. And what happens is we have a couple of theorems at first. It says if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. Here's what you need to remember. This is the important part. If you have a long side, it goes with a big angle. Medium side, medium angle. Small side, small angle. So in this picture, I've labeled the three sides of the triangle with 12, 10, and 6. You should go ahead and label them that way also. So notice this side, 12, is the longest side in the picture. The angle opposite that is angle R. And that means that if this is the longest side, angle R is the biggest angle. So the measure of angle R will be bigger than, well, our medium-sized side is this 10. And opposite from the 10 would be angle S. So angle R is bigger than angle S. And then the smallest side is the 6. And that 6 is opposite angle T. And so therefore, the smallest angle in our triangle is angle T. Okay, so when you know the side lengths, longest side, opposite biggest angle, medium, opposite the one in the middle, smallest, opposite the smallest. The second theorem says if we know about the angle measurements and the order they go in, that will tell us about the sides. So again, as far as remembering, a big angle or biggest angle goes with longest side, etc., etc. So if we take a look at our picture, I went ahead and wrote in these three measurements for the angles of this triangle. So we start by picking out that 92 degrees is the largest angle. The side opposite from that will be segment TS. And therefore, segment TS will be the longest side of our triangle. The next angle in size is this 56-degree angle. If you go to the opposite side from that, that takes you to segment TR. So that's our middle side. And then the smallest side will be opposite the smallest angle, and if we go across, that takes us to segment RS, and therefore that's the smallest side in the triangle. Okay, at the bottom of the page, we have the triangle inequality theorem, and this is a biggie. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. If this requirement is not met, you cannot form a triangle with the three segments. So in this picture, AB added to BC, these two sides must end up being longer than the third side, side AC. And then these are just all three possible combinations to meet the triangle inequality theorem. Now, the thing about this is, though, if I look at this picture and I can see that the longest side in this is probably side AC, I'd say that's the longest side of this triangle. Now, let's go ahead and just put numbers on these sides and see how that works. So let's say, for argument's sake, I knew this side was 10. We'll go back to the numbers we knew before. This side was 12. And this side happened to be, we'll make it a little bit longer, this guy's 8. So with that in mind, if I were to take these statements and put the numbers in for them, my first statement would be 10 plus 8 is bigger than 12. Well, yeah, that's true. The next statement would say AB 10 plus 12 must be bigger than 8. And the third statement, AC 12 plus 8 must be bigger than 10. Now, I want you to take a look here and see this statement. Okay, great, that makes sense. But when you look at this second statement, you'll notice that either 10 or 12 by themselves could have beaten 8. So there's no need to check if 10 plus 12 beats 8 because 12 by itself already did it. 10 by itself was already bigger than 8. So this one's kind of useless to you. And then I'm going to say, actually, I'm going to use a different word instead of useless. I'm going to say not helpful. How's that? Now, if you take a look also at this statement, 12 plus 8 is bigger than 10. Once again, 12 was already bigger than 10. We didn't even really need this second side. And again, because of that, this is not a helpful statement. So what it boils down to, the quickest check, you'll notice 8 and 10 are the two smallest sides of the triangle. And so if you want to, you can boil this down to check this theorem by adding two smallest sides and making sure they, or that sum, let's say, is greater than the longest side, okay? That is the practical application of the triangle inequality theorem, and we can see the two short sides, 10 plus 8, added together are bigger than the long side. Again, notice they must be greater. You are not allowed to have it equal to the sum. Okay, we're going to go on to page 2 and take a look at some examples. Okay, on page 2, we have these examples. We're going to just do a couple of these. Let's do number 3. And number 3, if you take a look, we have 3y, 4y, and 5y, and we're being asked to list the angles in the triangle from least to greatest, so smallest to largest. So when I take a look at these three sides, which side will be the smallest side? Good, 3y. Which side is the medium side? 4y. And which side is the longest side? 5y. So with that in mind, the smallest side will be opposite the smallest angle. So our smallest angle is angle J. And its measure will be less than, here's the medium side, it goes across to the medium angle. So that'll be less than the measurement of angle L, which will be less than, and again, our longest side is 5y. It is opposite angle K, our biggest angle. Okay, so keep that in mind. You should, on your own, set up number 1 and number 2. Moving on to the example number 4. Example number 4 gives you this triangle, and we're being asked to list the sides from shortest to longest. And notice they just haven't given you the third angle of the triangle. So the first thing you should do is subtract from 180 to figure out that third angle. So right now, these add up to 115, which means that this must be 65 degrees. Okay, once you know that, again, small angle, small side. So the smallest angle is 54, so the smallest side is MO. The medium-sized angle here is 61, and its opposite, NO. And then the longest side will be opposite the largest angle, which means that would be NM. And there are the sides listed in order from least to greatest. For number 5, I recommend to try that one. The first thing you should do is draw a picture of a triangle and put the appropriate labels in. That'll help you list the sides. Okay, and the last example we want to look at on this page is at the bottom of the page. The shortest side in the diagram. So if I take a look here, again, I'm going to fill in the missing angles. This is 121, and therefore this is 59 degrees. These guys add up to 120, and therefore this would be 60 degrees. So I'm looking for the shortest side. So right now, in this picture, the shortest side over here is the 59 degree side, segment DC. But over here, the shortest side happens to be segment AC. But notice segment AC is shared by the two triangles, and in this triangle, it's the longest side, and therefore the shortest side here is segment DC. Okay, we're going to move on to the next page. Okay, on page 3, we're going to look at example B. We're being asked, can the triangle have sides with the given lengths? So to check that, you just take the two smallest sides, and be careful, they may not be in order. That would be 7 and 6. And I check, is 7 plus 6 greater than the longest side, 13? That is not true. And so this is not a triangle. Okay, moving on to this last example. In this example, you're being given two sides of a triangle, and you're being asked for the range of values for the third side of the triangle. So, because of triangle inequality theorem, I've written the 3 possible inequalities that must all be true for this to work. Now, you'll notice one of these is not helpful, and that would be this one, because again, 11 was bigger than 5 all by itself. It didn't matter what x was. So these two are going to be the two that are important to me. And you'll notice this one is already solved for x, and if you clean it up and turn it around, I like to turn it around, x is less than 16. For this one, if you solve, x is greater than 11 minus 5, or x is greater than 6. Now, that means that as long as I pick a number bigger than 6 and less than 16, I will have a viable answer for x. Notice, they don't have to be integers. It could be 6.1. It could be 6.01. It just needs to be bigger than 6. So I also want you to notice my two numbers were 5 and 11. Well, 6 is formed by taking 11 minus 5, and 16 is formed by finding 11 plus 5. That is no coincidence. The boundaries for your values on the third side will always be the difference of the two known sides and the sum of the two known sides. So this one is subtract two known sides, and this side is add them. Okay, we are just about out of time, and stay classy.